All right, guys. Today I'm going to be going over our bank balance sheet worksheet that we did, as well as our money multiplier, and I guess it was also a little bit of balance sheets as well. These are both part of our Module 7 homework assignment. So let's get right to it. Number one up here was a simple balance sheet. I tried to do problems kind of in pairs. That way we can see the difference. So the only difference between these two is the required reserve ratio. So number one, we've got a bank balance sheet that has demand deposits of 1,000 and reserves of 1,000. So it says using the bank balance sheet above, what is the required reserve and the excess reserve of a 10% required reserve ratio. So what we have here is a T-chart where they're just giving total reserves. And that's going to be broken up into required and excess, number one. So if we have demand deposits of $1,000 and it's a 10% required reserve ratio, that means our required reserve is going to have to be 10% of 1,000. So the required reserve will be 100 and the excess reserve will be 900. This is what has to stay in the bank as required by law. This is what the bank can use for loans, to buy securities, whatever it wants to do with this money. This can become our new loans. Number two, same problem, same T-chart. Using the bank balance sheet above, what's the value of the required reserves and excess reserves at a 20% required reserve ratio? All right, so once again, our total reserves, put that right there, sorry about that. Our reserves here, again, were 1,000. We have our required reserves, and we have our excess reserves. This time they said 20%, so 20% of 1,000 is 200 bucks. Subtract them, you get your excess reserve of $800. Boom. Numbers 2 and 3, again, are going to use the same T-chart. This time I put more distractors or put more stuff into the T-chart. That way we can start to differentiate. This time the bank has demand deposits of $2,000. They have reserves of $500, and they have loans of $1,500. So they've already made loans of $1,500. So that is something that's bringing in revenue from them. But we're only going to be working with this 500 right here. So number 3, we have got total reserves, $500. They want to know what's the value of the required and excess at 10%. Required, excess, and it would be 10% of 2,000. So 10% of 2,000 is 200 bucks. So my required reserve is $200. 500 minus 200 leaves an excess of 300 bucks. Number 4, same thing. Oops. Great worksheet, Mr. Owen. What I intended was for that to be 20%. So now for the future, let's fix that and let's save it. We'll have to re-upload that to the Google Drive, or I'll repeat the same error again next year, because this is actually the second time that I haven't fixed that properly. So at 20%, even though we weren't technically supposed to do it, let's do it anyway. We still have a total reserve, 500 bucks. They want to know the required and the excess reserves. So this time, 20% of 2,000, or 2,000 sitting right there, would be 400. So the bank must hold 400 in required reserves based off of that $2,000 demand deposit right there. 500 minus 400 gives us excess reserves of 100 bucks. Okay. Number 4. That was number 4. Number 5. Using the bank balance sheet above, assume Mr. Minter deposits 1,000 into the bank. What is the new value of required reserves and excess reserves? So he's going to put in more money into this bank, $1,000. So when I think about money going in, I look at the deposit. I say, okay, this $1,000 is going to go into the bank. It's going to go into 2 places. It's going to go into the required reserves, and it's going to go into the excess reserves. They said the reserve requirement is 10%. So 10% of 1,000 is $100. So we would adjust our required reserves by $100, and excess reserves is going to increase by $900. Why? 1,000 minus 100 is 900. So they want to know what is going to be the new value of required reserves and excess reserves. So originally, required reserves was 50 bucks. Required was 50, but now we're going to add 100 to it. So our new required reserves will be $150. And our excess reserves were originally, move my mouse, originally 300. We're going to add 900 to that. So should be 1,200. Cool. So on our T chart, our required reserves would be 150. Our excess reserve would be 1,200. Alrighty. If we want to check our work, we could say, okay, 1,000, the deposit from Mr. Minner, went into the checkable deposits account that had 500 in it right now. So 1,000 plus 500. And let's multiply that by 0.1 to see what our required reserve ratio is on $1,500 at 10%. And it's 150. So we checked our work, we're good to go. All right, let's take a look at number 6. Okay, using the bank balance sheet above, assume Ms. Tellers deposits 500 into the bank. What is the new value of the required reserves and the excess reserves? So once again, this is a deposit. So when it's a deposit, I take that full amount, that $500. I assume part of it's going to go into the required reserve and part of it's going to go into the excess reserve. Now, our required reserve ratio is 20%. So 20% of 500 is 100. So the required reserve will be 100. Total went in was, sorry about that, as I'm off the page. 500 was our total deposit. 100 was required, so whatever is left over is our excess reserves. So if I go back over here, my required reserve was originally 800. We're going to add in another 100. So our required reserve increases to $900. And our excess reserve was originally $1,200. And now it's going to be $1,600. Cool. Alrighty. So that was 1, 2, 3, 4, 5, and 6. Let's flip this bad boy. This time I'll add my markers at the bottom of the page so I don't cut off on you guys again. Sorry about that. And my squiggly. All right, number 7. Using the bank balance sheet above, assume Ms. Taylor withdraws 500 from the bank. What is the new value of required and excess reserves? Okay, now when money comes out, I do the opposite. This time, when money comes out, I add together what I already have, and then I do the math on it. So required reserves plus excess reserves is $600. They had 100 in required and 500 in excess. So I'm going to lump those together, and I'm going to call that my total reserves. This is number 7, right? Yeah. So my total reserves is now $600. And then on this side, you had our checkable deposits. I'll just turn that into a T chart. So on this side, our checkable deposit was $1,000. All right. So what came out? 500 bucks. So 500 came out on this side. So the new balance of the checkable deposit at this bank is 500 bucks. On this side, if I take 500 out here, I have to take 500 out on this side. That leaves $100 sitting here in my new total reserves. They said the reserve requirement ratio is 10%. So I'm going to say what is our new required and our new excess reserves. 10% of 500 is 50 bucks. So my required reserves is 50 bucks. If my total reserves were 100, 100 minus 50 will give me my excess reserves. And we're good to go. Okay, that takes us to number 8. Put it right there. Using the bank balance sheet above, assume Mr. Santos withdraws $500 from the bank. What is the new value of required and excess reserves? So again, I'm going to lump the two numbers together. Required and excess together are 1,400. So I'm going to say total reserves, what, 1,400? And my checkable deposits were 2,000. Oh, duh. All right. So Santos has taken out 500, which means our checkable deposit is now at 1,500 bucks. My total reserve is going to have 500 come out of it, because if you take 500 out on this side, you take 500 out on this side. So let's take 500 out, and that leaves us 900 bucks in total reserves. So now we need to break this total reserves into our required reserves and our excess reserves. So to do that, we need to figure out what 20% of 1,500 is. $300. So my required reserve will be $300. 900 minus 300 will give us our excess reserves. And then we are good to go. All right, number 9. Let's flip that page again. Where am I at right here? Beep, 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 burp. All right, so number 9. Using the bank balance sheet above, assume the bank decides to issue $100 in new loans. Please create a new bank balance sheet illustrating the new account values. Cool. This one, we're not going to have to do much math. Why? Because they're just moving one asset to another. So let's make our assets, and yeah, that's supposed to be just one T, and liabilities. So checkable deposits were 1,000. Right now, they've got required reserves. We know required reserves aren't going to change because it's required by law, and it's 10% of 1,000 is 100. So required reserves, that's staying. Excess reserves. So they had $500 of excess reserves, so they could do whatever they want with it. What they're choosing to do is to issue $200 in new loans. So someone comes in and says, hey, I want to take out a loan. This bank says, well, I have $500 right here sitting in my excess reserves. I'll give you a loan. So that excess reserves is going to decrease by 200 bucks. So that drops to 300. And the loans were originally 400, but now $200 became new loans. So 400 plus 200 is 600. Still, we've got 100, 300, so 400, that's 1,000. We're still balanced, the bank balance sheet balanced. So that was number 9. And number 10, looks like I'm gonna have to move my big head so I can see all of it. The final one is, using the bank balance sheet above, assume the bank decides to sell off all of its government securities. Please create a new bank balance sheet illustrating the new account values. Again, this is great because we don't have to do any math. So number 10, we started off with our assets and our liabilities. So checkable deposits of $2,000. What's our required reserve rate? 20%. Our required reserves will stay exactly where it needs to be at 20%. It has to stay there. So no change in the required reserves over here. Excess reserves are going to see a change, and so will government securities. So government securities, they originally had 600, right? This says the bank decides to sell off all of its securities. So 600 bucks are going to be sold. So they now own no government securities. They sold them to people in the market, and those people gave them cash. Where do you put your excess cash? That's right, excess reserves. So that 600 would move over into our excess reserves. 1,000 plus 600 is 1,600. Double check our math. 400 plus 600, 1,600 is 2,000, and we are good to go. All right, so that was our bank balance sheet assignment. Oh boy, we're having a focus issue. Maybe it'll fix itself as I get these little stars on here. Or maybe, yeah, he wants his magic swirl. All right, so that one's gone. Let's bring up, oh boy. Come on now. Let's bring up this guy. Hey now. How about, yeah, right there. Come on. Okay, so we had 4 problems. Let me double check. 1, 2, 3. That's really it? 3? Okay. Okay, so it's 3. Bank balance sheets and multiplier practice. This one I thought was really important because it helps us to distinguish between the change in the demand deposits and the new loans or new money that a bank can make. So let's get this going. So number 1, we've got Mr. Cornforth discovers 10,000 worth of early American artifacts while hiking the Pacific Crest Trail with his family, and he deposits the entire 10,000 in his checking account. So he must have sold them. He deposits the entire 10,000 in his checking account at Bank of America. Assume a 20% required reserve ratio. All right. What is the total change in the demand deposit account of Bank of America? Well, demand deposit, part A is just going to be 10,000 bucks because he took that 10,000 worth of early American artifacts and dumped it into his checkable deposit account. Nothing gets held back in the checkable deposit account. So that one's simple. That's just $10,000. B says, by how much will the Bank of America have to hold in required reserves? So B is now saying, all right, you have, whoops, there we go. You have taken that $10,000 and you're going to break it into required reserves and into your excess reserves. So at 20%, what's 20% of 10,000? Should be 2,000 bucks. So $2,000 is going to be held in the required reserves at that bank. Part C says, what is the maximum amount of new loans that Bank of America can make? Well, Bank of America can take that 10,000, hold on to 2,000, and they have excess reserves of $8,000. This is the maximum amount that Bank of America can make, not the entire economy, because we're not talking about maximum change over time. This one is going to ask about the change over time. This is saying Bank of America. Since we don't know what their excess reserve was before he put the money in, we'll just assume it's a goose egg. So as a result of that $10,000 deposit, what's the maximum change over time in the money supply? For that one, we take the initial new loans times our money multiplier. And that will give us our total change in the money supply. Let's call that MS because that's what it looks like on our graphs anyway. So what is the initial new loans that they can make? 8,000 bucks. So, whoops, got ahead of myself there. $8,000 times our money multiplier. Uh-oh, what's our money multiplier? says our required reserve ratio is 20%. So our money multiplier is 1 over the required reserve ratio. And since our required reserve ratio is 0.2, our money multiplier is going to be 5. So 8,000 from our initial new loans that Bank of America can make times our money multiplier, 5, is going to give us the total change in the money supply. 8,000 times 5 will be 40,000 bucks. Cool. So that's one. Number 2. Mr. and Mrs. Neubauer discovered gold dust in the Colorado River while hiking and fishing. Last semester, they said when I give out this assignment, they need to cut out this hiking because they don't hike when they go to the river. They wakeboard and they chill. So sorry, I didn't update it. So if you guys have Miss Neubauer, you don't have to ask her about hiking. Tell her we heard that you were wakeboarding. So Mr. and Mrs. Neubauer find gold dust in the Colorado River while hiking and fishing on a camping trip. They receive 20 bucks for their reward and immediately deposit it into Western Union Bank, where the required reserve ratio is 10%. Cool. So we know that they just took in, make sure I'm on the screen, $20,000. I know where this problem's going, so I'm just going to set it up for it. It's going to have to go into the required reserves. It's going to have to go into the excess reserves. And our number is 10%. So let's just keep that 10% just floating around up there. All right. How much will the required reserves of Western Union increase by? 10% of 20,000. Yeah, I'm just going to check that just in case. 2,000 bucks. So our required reserve is 2,000, which means 20,000 minus 2,000 will leave an excess reserve of 18,000. So 2A, 2,000 bucks. 2B, how much will the excess reserve increase by? 18,000. Required reserve was 2,000. 20,000 minus 2,000 is 18,000. C, what is the maximum amount of new loans that can be created over time? Oh, okay, so that's not Western Union. We're talking about over time. So as it multiplies in the banking system. So we're going to use this equation again. The initial new loans times the multiplier will be our total change in the money supply. My initial new loans in this case are going to be 18,000. Came right out of my excess reserve. Now I have to multiply by the money multiplier. To get my money multiplier, I'm going 1 over the required reserve rate, 10%. So 1 over 0.1 is a money multiplier of 10. So initial new loans, 1,800, multiplied by our money multiplier will give us our total change in the money supply, which will be $1,800. And then this one says, what is the initial change in the demand deposits account in our economy's banking system over time? So demand deposits, that's your initial deposit that goes in. And the equation is the same as this one, except for instead of initial new loans, it's our deposit times our multiplier. Yep, it's spelled multiplier wrong. Equals the total change in our checkable deposits or demand deposits, whichever term they're going to use. So in this case, we take our 20,000 times our money multiplier. So deposit times our multiplier will give us our total change over time. In our demand deposits, not new money, it'll always be larger than new money. So there we go. That's 2. 1 to go. Number 3. Give me a squiggly of love and support. And my markers so I know where the screen stops. All right, Mr. Drake invents a new type of golf bag that is lighter and more ergonomic, making it the most sought after bag at CIF this year. he deposits $80,000 in profit earned at the San Diego Federal Credit Union. Clearly, this is his mission fed moment. Clearly, that's a dad joke. The required reserve ratio is, yikes, it's huge. It's 25%. All right. So this is going to be a calculator problem. So Mr. Drake took in $80,000. Let's get an A. Took in $80,000. Part of it's going to have to go into required. The other part is going to have to go into excess. So let's figure out what's going on here. How much will the reserves of San Diego Mission Federal Credit Union increase by? Whoa, they just said reserves. They weren't specific. They didn't say required reserves. They didn't say excess reserves. So at this point, we know that it's going to be both, right? So it's just $80,000. They're not asking about required. They didn't ask about excess. If they don't specify which one, they mean total reserves. So trick question right there. And that actually happens a lot on the AP exam with this question. So reserves went up by 80,000. Over time, what is the maximum change in the economy's money supply as a result of that 80,000 deposit made by Mr. Drake? All right, so let's figure out what 25% of 80,000 is. 25% of 80,000 is 20,000. I probably should have been able to do that in my head, which means my excess reserve is 60,000. So now we're going to have to use our specific knowledge, because what's the maximum change in the economy's money supply? We're using our equation of our initial new loans times our money multiplier equals our total change in our money supply. So what is our initial new loans? Well, this bank can make initial new loans of $60,000. What's our money multiplier? We have a massive required reserve ratio this time. It was 25%. So our money multiplier is 1 over the reserve requirement, or 1 over 0.25. So with a large required reserve, you're going to have a small money multiplier. 60,000 times 4, initial new loans, 60,000 times our money multiplier, we solve for 4. Should be $200,040 or bucks. Cool. So that was right up there. Sorry, he was put in the wrong spot. And finally, why might the actual change in the money supply over time be smaller than the number calculated in Part B? Stole that right out of an FRQ. So why might the money multiplier not have its full effect? 60,000 should become 240,000 unless a couple things happen. The first one would be banks don't loan out all their reserve. Banks don't loan out all their excess reserves. Why might not they do that? Well, what if the people don't have good credit and they don't think that there are people out there that are worthy of loans, and they don't trust that they're going to get paid back, so they just don't do it. They've got the money, it's sitting there, they want to make the loan, but you don't want to give a loan to someone who's not going to pay you back. So that's our first one. What was the second one? The second one was leakage to cash and coin. Leakage to cash and coin. What does that mean? You get paid $1,000. You go to put it in the bank. In this example, the bank should have held on to $250 and then loan out $750. But instead of depositing my entire $1,000 in the bank, well, I'm only going to deposit, let's go with $500. So if I put $500 into this bank, I'm holding on to cash. That means the bank can't loan out as much. They took in 500. They're going to keep 25% of that, which I think is $125, and they should have 375 to loan out to other people. So that original amount, 750, isn't getting loaned out. Instead, it's 350 because I kept money in cash in my pocket. Maybe I'm planning for Mother's Day. Maybe I'm planning for a rainy day. Maybe I just want some VGs and I need some cash. So They don't loan out all their excess reserves, leakage to cash and coin. And the third one, even though, like I said in the last one, I don't think it's really a third one, is time. That takes a very long time for all the money to multiply through the system. So boom, that was our homework assignment last night, Module 7. Module 8's homework assignment is really quick. There's only like 4 parts. This is the one I was like, hey guys, this one's going to be a heavy assignment this week. After this, we have one more formal type lecture, and then it's going to be kind of a practice sesh for Unit 4, and then we're just going to review. I'm going to go into a dead week for our AP exams. You guys are awesome. Great to talk at you, and I hope you are doing well, and I am out.